Hello students and viewers, welcome again to the lesson of today. This is a Teta from Morogoro, Tanzania. My name is teacher Ramadhan Kadeghesho, a teacher of chemistry. Today I will go to share with you one of the Form 3 topic, which is called acids, bases and salts. This topic comprises 3 subtopics, which are acids and bases. The second one is indicator, and the third one is salt. So today I will teach you one topic which is called acids and bases. Starting with acids. Students, can you define acid? Very good. By definition, you can say acid is a chemical compound, or is a chemical substance, or is a compound which when dissolved in water produces hydrogen ion as the only positive ion. I will repeat again. When you are talking about acid, by definition, you can say is the chemical substance which when dissolved in water produces hydrogen ion as the only positive charge ion. For example, we have a lot of acids. For example, hydrochloric acid. I mean, when it is dissolved in water, it will produce the hydrogen ion and the chlorine ion or chloride ion. So the hydrogen ion is produced there. So that's one is an acid. Another example is the sulfuric acid. When the sulfuric acid dissolved in water, produces hydrogen ion and the sulfate ion. So the hydrogen ion is produced there. Another example of acid is ethanoic acid, or in another name we can call it acetic acid. So when it is dissolved in water, the ion which are produced there is hydrogen ion and the ethanoate ion. So the hydrogen ion is produced there. Now let's go to discuss another part which is called the nature of acid. Nature of acid. So the word acid itself comes from the Latin word acidus, which means sour. The word acid comes from the Latin word acidus. The meaning of that acidus is sour. So the natural sources of acid, we have plenty of natural sources of acid, including let's look at the acid and its source. The first one is carbonic acid. The source of carbonic acid is soft drink. Another is oxalic acid. The source of oxalic acid is spinach. Another is acetic acid. This one is obtained from the vinegar. Another is lactic acid, and the lactic acid is obtained from sour milk. And another one is citric acid, and these are obtained from citrus fruit like orange and others. Now let's look at the laboratory acids. I mean the acids which are used in the laboratory for various experiments. There are 3 common acids which are used in the laboratory for various experiments, including hydrochloric acid. Another is sulfuric acid, and the last one is nitric acid. So these are acids which are commonly used in the laboratory for scientific experiments. Now we are going to discuss another thing which is called physical properties of acid. We're going to discuss here, I'm going to explain to you the properties of acid, starting with the physical properties of acid. The first one is acid have a sour taste. Acid has a sour taste. Another, acid turn blue litmus paper red. I mean the blue litmus paper can be turned into red if it is in acid. And another one, acid is more corrosive, is corrosive. So it is corrosive. I mean it can corrode various materials like body, metal and others. So these are physical properties of acid. Out of that, we have a chemical properties of acid. We have a chemical properties of acid. The first one, acid react with metal to produce hydrogen gas. The first chemical property of acid, acid can react with metal to produce hydrogen gas. So if you take acid and then you react with metal, the product which is formed there is a metal salt and the hydrogen gas. For example, if you take the hydrochloric acid and then you react with iron, the product which is produced there is iron chloride and hydrogen gas. Another example is the reaction between sulfuric acid and zinc. If you react, the product which is produced there is zinc sulfate and hydrogen gas. Another example is the reaction between nitric acid and copper. The reaction between nitric acid and copper, the product which is produced there is copper nitrate and hydrogen gas. So this is the reaction between acid and metal. But the point to note is that most reactive metal like sodium and potassium should not in such experiment. Because they are explosive. So these metals are very explosive. So they cannot be used in the production of hydrogen gas. The second chemical properties of acid, the acid react with the base to form salt and water. So the reaction between acid and base, the salt and water is produced. So if you take the acid and then you react with the base, the product is metal salt and water. For example, the reaction between hydrochloric acid and sodium hydroxide. So the hydrochloric acid react with maybe calcium hydroxide to produce calcium chloride and water. Another example is the reaction between sulfuric acid and potassium hydroxide. So the reaction between sulfuric acid and potassium hydroxide, the product is potassium sulfate and water. Another example is the reaction between nitric acid and sodium hydroxide. The product which is produced there is sodium nitrate and water. So this is the reaction between acid and base, and the product is salt and water. Now the third chemical properties is acid react with carbonate to produce salty, carbon dioxide and water. Acid react with carbonate to produce three products, which are salty, carbon dioxide and water. For example, if you react hydrochloric acid and calcium carbonate, the product which is produced there is calcium chloride, carbon dioxide and water. Another example is the reaction between sulfuric acid and sodium carbonates. The product which is produced there is sodium sulfate, carbon dioxide and water. Another example is the reaction between nitric acid and calcium carbonate. Nitric acid and calcium carbonate. The product which is formed there is calcium nitrate, carbon dioxide and water. So this is the reaction between acid and carbonate. Another chemical properties is acid react with hydrogen carbonate to produce salty, carbon dioxide and water. Also, acid react with hydrogen carbonate to produce three products, which are salty, carbon dioxide and water. For example, the reaction between sulfuric acid, hydrochloric acid and calcium hydrogen carbonate. The product which is formed there is calcium chloride, carbon dioxide, and water. Another example is the reaction between sulfuric acid and sodium hydrogen carbonate. The product which is produced there is sodium sulfate, carbon dioxide, and water. And another example is the reaction between nitric acid and calcium hydrogen carbonate. What is formed there is calcium nitrate, carbon dioxide, and water. So these are few chemical properties of acid. And here we have seen the reaction between acid and metal. Also, we have seen the reaction between acid and base. Also, we have seen the reaction between acid and carbonate. Also, we have seen the reaction between acid and hydrogen carbonate. Point to note, not all substances contain hydrogen is acid. Not all substances which contain hydrogen is acid. Because other compound, its hydrogen atom cannot ionize when dissolved in water. So there are some compounds which contain hydrogen atom. There are some compounds which contain hydrogen atom. But when they dissolve in water, those compounds, the hydrogen atom of those compounds do not ionize. So such compounds are not regarded as a acid, are not regarded as an acid. For example, sodium hydrogen carbonate. The sodium hydrogen carbonate contains hydrogen atom. But when dissolved in water, the hydrogen ion is not formed. Another example is sugar. Also, sugar contains hydrogen atom. But when dissolved in water, do not form hydrogen ion. So such compounds are not regarded as acid. After that, now we are going to discuss another thing which is called strength of acid. Strength of acid. Due to the degree of dissociation, when dissolved in water, acid can be classified as we have strong acid and we have weak acid. Here we look at the degree of dissociation when the acid dissolves in water. So when it's dissolved in water, the acid can be classified as strong acid or weak acid. Now, starting with a strong acid. Students, can you define strong acid? Good. By definition, you can say strong acid. This is the acid which, when dissolved in water, dissociate completely into ions. Strong acid is acid whereby all atoms present in acid dissociate completely when dissolved in water into negative ion and hydrogen ion. For example, for strong acid, we have hydrochloric acid. When the hydrochloric acid dissolved in water, it produces hydrogen ion and the chloride ion. Another example of strong acid is sulfuric acid. When the sulfuric acid dissolved in water, produces hydrogen ion and the sulfate ion. I mean, all atoms dissociate into ions. Another example is nitric acid. And this nitric acid, when dissolved in water, dissociate into hydrogen ion and the nitrate ion. So these are examples of strong acid. Also, I said that we have a weak acid. Students, can you define weak acid? Very good. By definition, you can say weak acid is the acid whereby all atoms present dissociate partially when dissolved in water. Is acid whereby all atoms present dissociate partially when dissolved in water into hydrogen ion and a negatively charged ion. For example, acetic acid. Acetic acid is a weak acid. When dissolved in water, dissociates partially into ethanoate ion and the hydrogen ion. This is one of the examples of weak acid. Now, we are going to discuss another part, which is called the concentration of acid. What are we going to discuss now is the concentration of acid. The concentration of acid is the quantity or amount of a substance in water. Or quantity of a substance in water. That's a definition of concentration. So the concentration is the quantity or is the amount of a substance which is dissolved in water. So when we are speaking about the concentration of acid, this is the quantity of acid present in water. Maybe the quantity of sulfuric acid which is present in water, that's the concentration of sulfuric acid. Or the quantity of hydrochloric acid which is present in water, that's we call it the concentration of hydrochloric acid. Now here in concentration of acid, we have the concentrated acid and also we have a diluted acid. So if the acid contains very little amount of water or not at all, that's what we call a concentrated acid. So the concentrated acid, this contains a little amount of water or not at all. But the diluted acid, this contains a more amount of water. So if the solution contains more amount of water, the acid is called diluted acid. So point to note here, both weak and strong acid can either be can either be concentrated or diluted acid. Both weak or strong acid can either be concentrated acid or weak or diluted acid. Now, we are going to I'm going to explain to you another thing which is called the basicity of acid. Another thing which I'm going to explain to you is basicity of acid. Students, can you define basicity of acid? It's okay. By definition, you can say basicity of acid is the number of hydrogen atom per molecule of acid that can be replaced by metal. These are number of hydrogen atom per molecule of acid that can be replaced by metal in a solution. Now we have some examples here of basicity of acid. So the table below here shows the basicity of acid. Here we have the acid and also I will show which kind of basicity is. Now hydrochloric acid. The number of hydrogen atom which is present in hydrochloric acid is 1. So for that case, the hydrochloric acid is regarded as monobasic. Another example is the nitric acid. The number of hydrogen atom present in nitric acid is 1. Also, this one is regarded as monobasic. Another example is the ethanoic acid. Also, the number of hydrogen atom present in ethanoic acid is 1. For that case, ethanoic acid also is regarded as monobasic. Another example here is the sulfuric acid. The number of hydrogen atom which is present in sulfuric acid is 2. So the sulfuric acid is regarded as dibasic. Another example is the phosphoric acid. The number of hydrogen atom which is present in phosphoric acid are 3. For that case, the phosphoric acid is regarded as tribasic. So we have a monobasic, dibasic, tribasic. Another thing which I'm going to explain to you is the uses of acid. Uses of acid. And here I will show the uses of each of the common acids which are present in the laboratory, starting with the sulfuric acid. The uses of sulfuric acid. First, it is used to remove rust from metal. The first one, it is used to remove rust from the metal. So the acid can also be used to remove rust from the metal, from the iron and steel. Can be used to remove rust from the iron or steel. Another use of sulfuric acid, it is used to manufacture synthetic textile, such as nylon. So synthetic textile like nylon also are manufactured by sulfuric acid. Another, it is used to make a fertilizer. So we have acidic fertilizer which are manufactured, which are made by sulfuric acid. Another one, it is used to produce sulfate. So the sulfate also is produced by sulfuric acid. Another use of sulfuric acid, it is used in the production of hydrogen and oxygen by electrolysis process. So by electrolysis process, we can produce hydrogen and oxygen gas from sulfuric acid. So these are some uses of sulfuric acid. Now let's look at the uses of hydrochloric acid. The hydrochloric acid is used in the production of chlorides. So the chlorides are produced by hydrochloric acid. Another use, it is used for electroplating. It is used for electroplating process. Not only that, but also it is used to manufacture fertilizer. Another use, it is used to manufacture rubber. So these are uses of hydrochloric acid. Now let's look at the uses of nitric acid. So the nitric acid is used to manufacture fertilizer. So also fertilizer can be manufactured by using nitric acid. Also nitric acid are used for explosives. Issues concerned with explosive, the nitric acid are used. Not only that, but also it's used to manufacture nylon. Also, the nitric acid is used as an oxidizing agent to clean metal. It is used as an oxidizing agent to clean metal. So these are some uses of acid. After all that, now we are going to discuss another thing, which is called bases. As we said that, the subtopic is called acids and bases. Now we are going to discuss another thing which is called bases. So students, can you define base? Good. By definition, you can say base is a chemical substance or is a compound which, when dissolved in water, produce hydroxyl ion as only negatively charged ion. By definition, you can say base is a chemical substance or is a compound which, when dissolved in water, produce hydroxyl ion as the only negatively charged ion. Also, base can be defined as the chemical substance or is the compound of oxide, carbonate, or hydroxide, which neutralize an acid to form salt and water. So this is a compound of oxide, carbonate, and hydroxide, which neutralize acid to form salt and water. Now, examples of bases including, we have a sodium hydroxide, which are present in sodium hydroxide when dissolved in water, including sodium ion and hydroxyl ion. Also, we have a ammonium hydroxide, Ammonium hydroxide is another example of what? Is another example of base. So the ion which is present in ammonium hydroxide is the ammonium ion and hydroxyl ion. Now, I'm going to explain to you the natural sources of base. Here, we are going to look at the base and its source, starting with the first one, which is the ammonia. The ammonia is found in gills of fish. Ammonia is found in gills of fish. Another is a methylamine. This methylamine is found in decaying fish. So this is a base which is found in decaying fish. Another is a ethylamine. This ethylamine also is found in decaying fish. We have a pyridine. This is a base also which is found in coal tar. Pyridine. It is found in coal tar. Another is a cadaverine. This is found in decaying flesh. So these are some bases and their sources. Out of that, we are going to look now the common bases which are found in the laboratory. The first one is the ammonia solution. When I'm speaking about ammonia solution, means is ammonium hydroxide. So this is ammonium hydroxide is found in the laboratory for various experiments. Not only that, but also we have metal oxide. Metal oxide are sodium oxide, potassium oxide, calcium oxide. All these are basic oxide. Another is a metal hydroxide, including sodium hydroxide, potassium hydroxide, calcium hydroxide, and others. So all these are acids which are, all these are bases which are found in the laboratory, and they are used for various experiments. Now, I'm going to explain the classification of bases. Classification of bases. The bases can be classified into two parts. Which are those? The first one, we have a basic oxide, and the second one, we have a basic hydroxide. So we have a basic oxide and we have a basic hydroxide. Now, starting with the basic oxide. Students, can you define basic oxide? Good. By definition, you can say basic oxide is the base of oxide compound. This is the base of oxide compound. For example, calcium oxide, sodium oxide. So these are examples of basic oxide. Also here in basic oxide, there are two classifications of basic oxide. We have a soluble oxide and we have insoluble oxide. So soluble oxide are called alkalis and insoluble oxide are called basic oxide. Also the basic oxide, hydroxide, these are bases of hydroxide compound. For example, calcium hydroxide, potassium hydroxide, these are examples of basic hydroxide. And the classification of basic hydroxide including soluble hydroxide, which are called alkalis, and insoluble hydroxide, which are called basic hydroxide. From this point here, today I will end here. Thank you very much for listening.